Okay, so welcome back once again, guys. And now in this lecture, so I'm going to show you that the embedding that we were able to create, a function we were able to write, and where we were using URI embeddings. And inside URI embeddings, so obviously we were using OpenAI model, OpenAI small model, and it was able to convert my data into its respective embeddings. Now, in this lecture, I'm going to show you that how we can try to use one of the available vector database in a market. One of the best one, by the way, obviously I'm going to show you because we have a lecture about detail, like in very detail, we are going to talk about a vector database in your upcoming session. So if you will go through your entire lecture, so you have that lecture as well, where I'll be talking about each and every operation with respect to a vector database. But as of now, what I would like to show you over here is that how we can try to store this embeddings in one of the vector database. A vector database which I can configure in my local system immediately just by doing a pip install, and then inside that I will be storing the entire embeddings that I'm going to create with respect to my own data set. So let's go ahead, let's try to do it one by one. So I believe my screen is visible to all of you. So here what I will do is that I'll try to take the help of this function, so get embedding function, and I'll try to convert my entire data, the chunks which I had already created, and chunks is coming from my founder story.txt data, and then I'll try to store it inside a vector database. Let's do it in a step-by-step manner. Believe me, you all are going to enjoy it. So which vector database we are going to use? So we are going to use a Facebook AI similarity search database. So as of now, this database will not be available inside your local. So what you have to do is, so you have to do pip install, 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 and then FAISS, Facebook AI similarity search -CPU. So just try to execute it, and it will be able to install. In my environment, it's already installed because while creating a material, I have already tested it. But yes, in your environment, it won't be installed. So please try to install this one. This is important. Now, once you are able to install, because in no time you will be able to install this one, then try to import. Import what? Facebook AI similarity search. Just try to do the import so that I will be able to use it. Now, this vector database is basically going to work in your local system inside your memory itself, and it is going to hold all the vector. So whatever data that you would like to store, it will be able to store all of those information locally as of now. Going forwards, I'll be using a Pinecone, I will be using a Waviate, I will be using a ChromaDB to perform a exact similar kind of operation going forward, right? But as of now, let's try to use a Facebook AI similarity search, which is going to help me out in terms of, storing a data. Now, how this vector database works internally, I'll try to give you a glimpse. But like I said, so we have a separate lecture for all of these vector database itself. So going forward, obviously, I'm going to teach you in very, very depth about all of these databases and its respective functionality. So now, let's do one thing. So let's try to basically create embeddings, and then one by one. So let's try to store all of these embeddings into a vector database, which is a Facebook AI similarity search that we are going to use over here. Okay. So let's do it. So here for that, what I can do is maybe I can try to write a small piece of a code over here, right? A small piece of a code over here. So let's try to write down the small piece of a code. So whenever we have to store any kind of information into a vector database, I have to tell that, okay, so what is a size of your embeddings? Yeah, what is the size of the embeddings? So that it will be able to, create that kind of indexes internally, and then it will be able to store your information. It will be able to store your data inside a vector DB. How we are going to do it? So if you remember, so here we have done this test embeddings, right? We have done this test embedding. Now, if I'm going to show you this test embedding, right? Test embedding. So this was my one of the sample embedding which I was able to create. Yeah, sample embedding which I was able to basically create. Okay, that's cool. Now, so out of this, if I have to extract a dimension, so maybe I can try to write a shape over here. So shape is going to be this one. Now this is a tuple. So I have to extract 1536 out of this tuple. So I can try to write a 0 over here. So this is the vector dimension. This is the vector dimension that I was able to create. So let's try to store it in a variable called as dimension variable. Okay, so this is the dimension. This is going to, this number is representing. I can hard code it, this number. That's completely fine. I can even hard code it, but I'm just trying to keep it dynamic. So 1536 is going to be a dimension of your vector space. Now what we can do is, so we can try to call a Facebook AI similarity search over here. And then there is a function called as index flat L2. So this is something that I'm going to call, and inside this I'm going to pass a dimension. So this dimension that I have created, so that it will be able to understand that, okay, so whatever indexes or whatever data that we are trying to store, what is the size of that data, what is the length of this data, what is the shape of this data, it will be able to understand in this way. So I'm going to create a indexes, because inside the indexes I'm going to store all the information. Okay. Now here, what I will do is, I'll try to create basically one variable. So chunk chunk underscore mapping, chunk mapping. And this is just going to be the empty list as of now, right? Empty list as of now. Now, my responsibility is to convert the entire chunk, the 7 chunk that we had. So one by one. So convert those 7 chunk, and then store it inside this particular database. That's my whole responsibility. That's my whole idea. Okay, so let's do it. So here what I will do is, so for like a chunk in chunks that we have created, the original one. So one by one, try to fetch all of these chunks. So 7 chunk that we have. And then try to call a get embedding function, and just try to pass a chunk one by one inside this. So this is going to return me what? This is going to return me the embeddings, 1536 vector space. So embedding it is going to return. Now once it is going to return the embeddings, I just need this one, right? So you can try to do what? So index of Facebook AI similarity search indexes dot add. Simple, right? Dot add. So add this indexes one by one inside your vector database. So whenever you are trying to add some of the indexes inside the vector DB, for example, a Facebook AI similarity search, so here you have to basically convert this entire things into a NumPy array, and you have to define basically a data type for that. Then only you will be able to insert it. So here I'm going to call NumPy array. This is just a provision which has been defined. And it is going to take embeddings basically. So whatever like embeddings one by one that we are trying to generate from this get embedding function, the function that we have already written. And then data type is as a type I'm going to define, and data type should be float, float 32. Yeah, float 32. So it is going to add one by one everything inside the indexes. As simple as that. And here, so maybe I can try to like call chunk mapping, which is nothing but an empty list for me, and then append what? So append all the chunk one by one, try to append all of this chunk over here. Now this operation, only this operation, I would say only 2 line of operation will be responsible to store this entire information, into a Facebook AI similarity search vector DB, where it can store, where vector DB has been designed to store all of these embeddings. So if I'm going to execute it, it is going to do its work. As you can see, it is trying to like take some sort of a time, because it is trying to call my URI, right? It is trying to call my URI, it is trying to get the embeddings one by one. If you would like to print those embeddings, you can try to print those embeddings as well for the verification. So embeddings one by one, it will start printing. See, for the first, second, it is able to create the embedding. For third, it is able to create the embedding. For fourth, it is able to create the embedding. Fifth, and then sixth, and then for a seventh, it is able to create the embeddings. This is something that we are trying to store where? This is something that we are trying to store inside my indexes. Yes, inside my indexes, the indexes or the object that I have created inside my Facebook AI similarity search. But still over here, you will not be able to see any kind of a database. So to do that, you have to store this indexes. You have to save this indexes. You have to persist. As of now, it will be available inside your RAM, inside your main memory. Okay, fine. So if I have to store it, how I will be able to store it? So simple, Facebook AI similarity search, just try to call and then try to call a write index function. So whatever indexes that we have created, we can try to write it down. So we can try to give a file name over here called as index.faiss. Any file name like you can try to give over here, faiss, with the extension index.fuzzy. Now object index flat to faiss, I have to keep it as a string. Okay, so now if I'm going to execute it, you will be able to see a file. So it has created a index.faiss, and yeah, so this file is basically, if I'm going to open it up, you will not be able to like understand this particular file because it is trying to store it in its own object format, So successfully we are able to invoke one of my vector database, which is a Facebook AI similarity search, and then I'm able to store all of my data, which is embeddings inside this particular database. This is how easy it is, guys. Again, so if I'll talk about a ChromaDB, if I'll talk about a Weaviate, if I'll talk about a Pinecone going forward, you will be able to find out that it's very simple. It's just a database, right? So just like a SQL database or NoSQL database, where we try to store a different kind of an entity as per the definition of the database. So here we are trying to store what? We are trying to store this one. Yes, we are trying to store this one. Simple. Yes, simple. We are trying to store this particular one. So hope all of you are able to understand that how we can try to invoke our vector database, and then I can try to store my entire embedding which I'm able to create from my embedding model into a vector database. Simple, right? Simple. Now what is our next step? So next step is going to be, so as of now what we are able to achieve, so we are able to convert into our embeddings, and now all of these embeddings are available into my vector DB, right? So we are here. So all these informations are available, my private information, by the way. So whatever data that I have taken, so my private information is available inside a vector DB. Now what is our next step? So next step is to perform a query operation, right? To perform a query operation. Now whenever I'm going to perform a query operation, right? Whenever I'm going to perform a query operation over here, so it should convert my query. It should convert this particular query into a embeddings, right? Into an embeddings, and then it should search where? It should search inside the vector database, right? It should search inside a vector database. So top K rank value or top similar search, it should be able to extract, and then it should pass this one to the LLMs. This is what we need. So whenever I'm going to query anything, it should search into the vector database. This is what I have written even over here, right? Even this flow is going to do the same. So we are going to search into a vector database for any query. So we are not going to hit our LLM directly. Generally, when we do a chat with a ChatGPT kind of a model, so what we do, we just write a query and we are hitting a ChatGPT model, and ChatGPT model will start generating a response, but not here, not in case of a RAG. In case of a RAG, whenever there will be a query, right? Whenever there will be a query, so it is going to convert those query into a embeddings, the way we have converted our data into an embeddings, and then it is going to search into a vector database that with respect to this query, what is the information which is available, because it has to answer with respect to my private data, right? It has to answer with respect to my private data. So it is going to search into a vector database, by the way. It is going to search into a vector database. Now, vector database is going to give you a return, maybe a top K value. It is going to return means as like a top 3 similar result, or maybe top 1, top 2, top 5, top 10, whatever that you are looking for. So top result, it is going to return, right? It is going to return. So we are going to attach our query, plus we are going to attach the return that we are able to receive, the embeddings that we are able to receive. We have to add it as I have mentioned over here, add symbol. So we have to add it, and then this will go, right? This will go inside my LLM, so that my LLM will be able to do a formatting and it will be able to give me a final answer, right? Final answer. So this is something that we are going to do in my next lecture. So till then, thank you so much. Take care, everyone. And see you again in my next lecture. Hope all of you are enjoying this lecture.